Hello and welcome to Andy's Code Vault. Today I'm going to create a tutorial on how to make a Tetris clone using Unity. I decided to kick off my channel with a Tetris tutorial because it is a great beginner project. It's not too ambitious and it's a really fun game to make and play. So let's get started. So here we are with an empty scene in Unity, and the first thing I'm going to do is create my Tetromino shape. I'm going to do that by creating an empty game object. I'm going to call it Tetromino-T for the T shape. I'm going to create another empty here, call it the model, and that model is going to contain all my cubes. So I'm going to create a cube, and then I'm going to duplicate it 3 times by pressing Control D. And this one's going to be 0, 0. It's going to be the first cube. And then I'm going to move this one over to the left, and then it's going to be -1. This one I'm going to move it to 1. And this one I'm going to move the Y to -1. So here's our basic Tetromino shape. It needs some color, and also I'm going to add some texture to it. I'm going to add texture using paint.net. So here I am in paint.net, and the first thing I'm going to do is resize the canvas to 64 by 64. Let's zoom in a little bit. I'm going to add some noise. I don't want any color saturation. It's just going to be a black and white, and I think I'm going to set this to 75. Now I'm going to add another layer to draw a border. So I'm drawing my border here. I only want this to be 1 pixel, so I'm going to decrease the size of the border. I think that looks good. Now I want to select the outside here, and I'm going to go select back to my background layer. I'm going to delete the outside of the cube, and then I'm going to merge the 2 layers together. I'm going to go over here and do a blur and set the radius to 2. I think that looks pretty good, so I'm going to go ahead and save it. I'm going to call it cube texture. Alright, so here I'm back in Unity. First thing I'm going to do is create a new folder for this texture. Okay, I'm going to move the texture onto each cube. Then I'm going to go over here and change the color. Let me do a red color for the T shape. Now if you notice that when I did that, it actually created a new materials folder and added a new cube texture material. And I'll use that for the texture for all my shapes. Now I want to add some movement to my Tetromino shape. So I'm going to go ahead and create a scripts folder. Alright, so I've created the Tetromino script, and basically it's going to control the Tetromino shape. It's going to allow us to move it around and rotate it. So I'm going to go ahead and delete the start method. We're not going to use that right now. We'll just go directly into the update method. Okay, so I've added an if statement here to check the horizontal axis, and we're going to check if it's greater than 0. And if it is greater than 0, then we're going to go ahead and translate the game object over 1 unit. Okay, now I'm adding the code for the opposite direction, and in that case we're going to translate to the -1 axis direction. So let's go ahead and test this and see how it works. Before we test this, I'm going to go ahead and move the camera down here. I'm going to reset this position, and I think I'm going to move the camera back a little bit to like -20, and move the game scene camera back a little bit. So I'm going to go ahead and drag the script onto the Tetromino shape. Now I'm going to go ahead and run it. Okay, it's moving, but way too fast. So I want to slow this down a bit, but how am I going to do that? Let's go back to the code. So if I slow it down by changing these values here to a smaller number, it's not going to move 1 unit at a time. And that's one of the things I want to do in this game, is make sure everything is always aligned on a grid. So I want to make sure I move everything 1 unit at a time. And also another thing about this is this movement is not being constrained by time in any way. So if the game runs faster on different machines, you're going to get a different gameplay, and I don't want that. I need to find a way to delay the movement without changing the unit movement. So what I'm going to do is put a delay on the outside and not accept any input unless a certain amount of time has passed. Okay, so I've added a couple of variables. Here I've added a const called movement delay, and that's going to be set to 0.25, which is going to represent 1/4 of a second. And then here I added a float to track my last move time. So now I've added an if statement, checking to see if the time is greater than the last move time plus our movement delay. And that'll prevent the Tetromino shape from being moved too fast, while at the same time preserving our 1 unit of movement. But one thing I need to do is I need to set the last move time. So I could do it right here in this if statement, and then I would also need to do it here in this if statement. That would mean repeating myself. So what I'm going to do is create a new method called move. So in my move method, I'm going to translate the game object to the vector3 that's passed in and update my last move time. So then up here, I just need to call the move method. Instead of the transform.translate, I'm just going to call move. And same with over here. Okay, so let's try it out. Alright, the movement seems pretty good and I like that speed. We might adjust it later once we start getting more of the game elements in. But for right now, that's pretty good. Okay, so I moved my movement code into a method called handleMovement, and I'm calling that from the update method. So next I'm going to create a method called handleRotation. I'm going to use a little trick here in Visual Studio to create this method for me automatically. So I'm going to press Control dot here. I'm going to tell it to generate the method Tetromino.handleRotation. And here you can see it's implemented for me, but I don't want to throw an exception, so I'm going to delete that. So for my rotation, I'm going to need some more class variables. I added a const for rotate delay and set it to ½ second. And then I added another float called last rotate time. Okay, so now in my handle rotation method, I'm going to do the same thing I did as the movement. Check the time is greater than the last rotate time plus the rotate delay. Then I'm going to check my vertical axis and rotate. And I need to go ahead and update the last rotate time. Okay, we're going to give this a try and see if this works. Alright, I'm moving around. I'm going to press up to rotate. And there we have it. Rotation's working. But you'll notice something interesting if I rotate and then start moving. Now I'm moving up and down. Now I'm moving the opposite direction of which arrow I'm pressing. So the movement is changing based upon the angle of the rotation. So the way I want to go ahead and fix this is I need to be rotating the model and not the outer game object. To do this, I need to keep track of the model's transform. So I've created a new variable called model transform. So I'm creating the awake method, and I'm going to use that to grab the transform from the game objects, the model's transform from the game object. And you do that using the .find method, passing in the name of the game object. And then in my handle rotation method, I'm just going to copy and paste my new model transform into the rotation. So let's give it a try and see if this works. Okay, so I'm moving, rotate, and there we go. My movement is still the same even after I rotate. So it's working as expected. Next, I want to implement the following of the Tetromino. So I've created 3 new class variables for my Tetromino. One is called fast falling, and the next is called normal falling, and then finally the fall speed. So I'm going to implement the handle falling method and delete this. Alright, so I've implemented my handle falling. So there's going to be 2 different fall speeds, and one is fast falling and one is normal falling. And if you hold the vertical down arrow, we're going to do fast falling. Otherwise, we're going to do normal falling. So that's just going to change the fall speed. Then over here we need to check if time.time is greater than our last fall time. By the way, I'm going to have to add this as a class variable because I forgot to do that. So if the time is greater than the last fall time plus the fall speed, then we're going to translate down in the y-axis and of course update the last fall time. So I'm going to go ahead and implement this up here and let's give this a run. Before we test the falling, I'm actually going to move this up a little bit so we can have more time to watch it fall. Alright, we're falling, we can rotate, I can go down for fast falling, rotate and move. It's good. So the next thing I'm going to do is create a container object, which is going to be the basic game playing field where all the Tetris pieces pile up. So I'm going to go ahead and create an empty game object called container, and I'm also going to give it a model as well. So the model is going to contain all of our objects that make up the container, the physical model. So the first thing I'm going to do is create a quad. So I'm going to adjust the scale of this to 10 in the X and 20 in the Y. I'm going to orientate my container. I'm going to reset that so it's at 0, 0. I'm going to rename this quad as the background. Okay, so I'm going to set my background to 0.5 in the Z position. And if we scroll in here, now we'll see that the Tetromino shape is going to be lined up almost perfectly with the background. That's exactly what we want. Okay, now I'm going to create a left cube, and I'm going to move that over to the left, -5.5, and then I'm going to set the scale for this to be 20, so it's the whole left side. Okay, I've duplicated the left cube and moved it over to and renamed it to the right, and then I moved it over here to 5.5. I'm going to create one more cube, go at the bottom, and move it down to -10.5. And I'm going to set the X scale to 12. And that looks about right for our container object. I think I'm going to move the camera a little bit so that it can see more, or actually I might zoom it in a little bit. I think it's a little bit out. Let's try 18. And maybe if I move the Y a little bit so that it's just, I actually want to move it out to a little bit more, 18.5. That's pretty good. And the Tetromino, I'll drop it to 11. Nope. 10. So now I'm going to create new materials for our container. I'm going to create material and rename it container background. I'm going to drag that onto the background. Then I'm going to take the container material and I'm going to select my image. I'm going to use the same cube texture, but what I'm going to do is some tiling. We go 10 by 20. There we go. And I think I'll change the color too. Let's do gray. Now I'm going to create a new material for the sides and do the same thing. Do it on the left and the right, and we're going to go ahead and do the tiling. It's going to be 1 in the X and set the tiling to 20. There we go. That's perfect. And I'm going to create another material for the bottom. There, just like that. And then I'm going to make sure and use the same color for the sides and the bottom. And then we have our container object. Let's go ahead and run it. Seems to fit pretty well. We go in the walls, of course. We haven't done our collision yet, and it's not quite lined up. Let's line it up first. So I'm shifting my model over in the x-axis by 0.5. And then that lines up my Tetromino shape just perfectly. And that looks good. We're not lined up in the y. Okay, and also I went in the y-axis by -0.5. And that seems to line it up perfectly. We're aligned in the x and the y-axis now. And it looks pretty good. So the next thing I'm going to write is the code for the Tetromino shape when it hits the bottom. I want it to hit the bottom and place the blocks on the board, basically, so it doesn't fall through. Basically add the collision detection. So to do that, I'm going to create a new C# script, call it container. Alright, so in my container script, I have this method called isBlockCollided, and I'm going to take in a list of vector2 ints called blocks, and that is going to represent all the blocks in our Tetromino shape passed in, and we're going to check to see if those have collided. Alright, so here in our isBlockCollided, I'm going to loop through each block in the blocks, and I'm going to check if the block.y is less than or equal to 10, then I'm going to return true, and that means we've reached the bottom of our container. And if we loop through all the blocks without a collision, we're going to return false. Before I continue, I need to make sure that I drag my container script onto my container object. Okay, and now I'm going to go back into my Tetromino, and I'm going to create a reference to my container script. So I'm going to say private container. Okay, so now in my awake method, I'm going to find the container object using the GameObject.find. This is a global search for all the game objects. Whereas up above here where we're getting our transform, we're only searching for child game objects or child transforms. Here we're searching for globally any game object or the first game object with the name container, and then we're going to grab the script from that using the get component method. And now we have reference to our container script, so we can reference the isBlockCollided method from that script inside of our Tetromino script. So in order to call this isBlockCollided method, I'm going to need a list of vector2ints of all the blocks. So I need a reference to all the block transforms. Okay, so here I have my m_block transforms variable, which is going to contain a list of transforms, which are going to be all the blocks in this Tetromino shape. Okay, so now I've added this add method to my list. So I'm adding to my list. I'm using the model transform and getting the first child and adding that to the list. And I'm going to do that for 0 through 3. Okay, so I'm getting all the child transforms because every Tetromino shape always has 4 blocks. So I'm going to grab all 4 of those blocks. Okay, so I've created this new method called getBlocks, and it's going to get a list of vector2ints of all the blocks positions inside the Tetromino rounded to ints. And we're also adding an offset here. And the reason we're adding the offset is so that we can predict where the piece is going to be in the future. So if we say, can we move left? We just do an offset to the left and then check for that collision. Adding in this offset is going to allow us to easily check left to right if we can do a move or not. Okay, before I add this to my handle falling, I actually want to refactor this fall method a little bit and make it a little bit simpler. And I'm going to copy and paste this value into that and call it from here, just to prevent this handle falling method from getting too large. I want to put an if statement here. So we're going to use our container. We're going to call that isBlockCollided method. We're going to pass in getBlocks and using a new vector2 int 0, -1. So we're going to look below us and see if there's a collision below us. And if there's no collision below us, then we know we haven't, we've hit the bottom. Okay, before I test it out, I actually need to set this block transform equal to a new list. Okay, let's test it out now. And when we hit the bottom, it should stop. Okay, it looks like we're one piece above. I'm going to move my model up a little bit so that -10 will be the bottom of the board. And that means I'm going to move the Tetromino shape up a little bit to 11 for its starting location. And now I need to move my camera just a little bit down. All right, let's run it again and see if it lands on the bottom. There we go. Good. Okay, so now I'm going to create just a cube. And this cube is just going to be a block, and it's going to get copied into the scene when the Tetromino shape gets placed down, and it's going to replace every single block in the Tetromino shape and place it in a container. So we're going to create this block object right now. So I'm going to use the cube texture for the block as well. And I'm going to create a new folder here for my prefabs. And then I'm going to move my block as a prefab. Delete my block out of the scene. Alright, so now I've created a new class variable in my container script for the block template. And that's going to hold that block prefab that I created. And I'm using this attribute here called serialized field. So that allows me to use a private variable, but it allows the Unity editor to go ahead and set this. Okay, so now back in my Unity editor, if I click on my container, I can now see that block template, and I'll go ahead and drag my prefab in there. And now I've set that. Alright, so I've got a new method here called setTetromino, and I'm going to call that from the Tetromino shape when it gets collided with another shape, either the bottom or another block. And what it's going to do is convert all these blocks into our prefab. Alright, so I'm doing a foreach through all the blocks, and I'm going to instantiate a new GameObject for each block using that block template. Now, if you notice this var keyword, it's basically a shorthand for whatever variable I'm going to assign it to. So for instance, this is a GameObject. So one thing about this instantiate, it's going to make this a global object, so it's just going to be floating in the scene. I actually want to add a placeholder to put all the blocks. So in my container script, I'm going to create an empty GameObject. I'm going to call it blocks, and we're going to use that to put all our blocks in that have been placed in the container. So I've created a new class variable called m_blocks transforms, and that's going to contain all my blocks. And I've created my awake method, and I'm going to use that to grab the transform, to find the transform for the blocks. So now that I've got this blocks transforms, I can use that in my instantiate method. If I add a comma here, this can be the parent game object. So it's going to create this new block and assign the parent to my blocks transform. So I'll be able to keep track of all the blocks. So the next thing I'm going to do is create another class variable to store all my placed blocks. And that way I'll be able to have a reference to them so I can search through them to see if there's any collisions. So here I have my class variable. It's a list of transforms called placed blocks transform. So then going back to my set Tetromino method, I'm going to add the new blocks transformed into my placed blocks transform list. So now if we go back to our Tetromino script and we go back to the fall method, we can set our Tetromino if it hits the bottom. So because I like to be positive, I'm going to get rid of the not here and I'm going to put the if collision method here first, and then else we're going to move the object. What we're going to do is call the container.set Tetromino, and what we're going to do is pass in the get blocks, but we're not going to use -1 anymore. We're just going to do 0, 0. Because there's no need to offset. We've hit the bottom and we're ready to place our block. So then after we set the Tetromino, the next thing we want to do is just destroy the game object. Alright, let's run this and see if it works. Okay, it looks like we're getting another error. It says another object reference not set to an instance of an object. So I think I know what I did. So I better go in here equals new list of transforms like that. So let's try it again. Okay, so now we look at our blocks and we only have 4 blocks on the board. So it's working. And you notice that our Tetromino has been deleted. So it is working. So now that we've placed our Tetromino onto the board, we need to be able to grab the next piece. And in order to do that, I think I'm going to create all of my Tetromino shapes right now and then add them as prefabs. What I'm going to do is I'm going to actually duplicate this 6 times. And the first one, I'm just going to go ahead and drag that one down as a prefab. And the next one, alright, so now I've got my I shape, now my J shape, and my L shape, and I got my O shape, and my S shape, and my Z shape. Alright, so I've got all of my Tetromino shapes completed. So now that I've got these created and saved as prefabs, I'm going to go ahead and delete them from the scene. So now I'm going to go ahead and update my script. I'm going to add another serializable field, and I'm calling it Tetromino templates. I'm going to set these in the Unity editor. Okay, so now that I've got my Tetromino templates over here, I'm going to go ahead and lock this in the inspector. I'm going to click on my prefabs and select them all and go and drag and drop them in the Tetromino templates. Now I have all my shapes in an array that I can use to instantiate new shapes when I set a Tetromino on the board, also at the beginning of the game. I need to set these as different colors because right now they're all red. I don't want to create a new material for each of these, so what I'm going to do is set these colors in code. So over here in my Tetromino script, I'm just going to create a public variable, call it color. Okay, so now that I've added that, I can actually go into my prefabs over here and set the colors. I'm going to make this one yellow. I need to make sure and set the alpha here to 1. Alright, so now I'm going to set all the colors for the other shapes. Alright, so I've got all the colors set. Okay, now that I've got all the colors set, I'm going to go over here in my Tetromino script in the awake method. And so what I'm doing is I'm getting components in children. So I'm grabbing all the renderers from this game object. So I've got all these blocks. I got 4 blocks in here, and I'm looping through all those and grabbing all the renderers. And I'm going to set those to the global color that we set. So that should set the color for the entire shape. And let's go ahead and grab a Tetromino. Alright, it's yellow, and make sure it still works. If it still falls, perfect. If you notice one thing, when we set the Tetromino shape onto the board, it reverted back to the red shape. We're going to have to set the color in our instantiate method as well when we do our set Tetromino method. Okay, so right here in our container script, in the set Tetromino method, let's do it right after we set the transform. We're going to grab the new block, get component renderer, set the material, .set color as, but what color are we going to set it to? Well, we probably need to pass in the color here. Because we don't know what color the shape is inside the container script, we only know that in the Tetromino script. script. So we need to go to our following method where we have set Tetromino, and then we need to pass in the color. Okay, so now let's give it a try. All right, here we go. All right, our block fell. We called the set Tetromino. We got our blocks here, and they're still yellow, so it's working good. All right, so now that we've set our Tetromino shape onto the board, we need to be able to call a method to get the next piece. All right, so here's my get next piece method, and the first thing I want to do is grab a random Tetromino shape. So I'm using the random.range method and passing in a number between 0 and the count of how many templates we have. And then I'm going to make sure that's an integer value using the floor to int method. And the floor means it's going to round down to 0 because the list is a 0-based index. The first element is going to be at index 0. Then I'm going to grab the template from the list of templates and then instantiate that template onto our scene and set the transform position. Going to set it to 11 in the Y. Okay, so because I want to keep everything in my container, I'm going to create a new empty game object and just call it Tetromino. And I'm actually going to put all my Tetromino shapes inside of this Tetromino placeholder. And also in my script, in my container script, I've got another class variable called a Tetromino placeholder. Then I'm going to use this Tetromino placeholder. When I instantiate my new Tetromino, I'm going to use that. Now in our set Tetromino, after we finish setting the Tetromino, we're going to call get next piece. So now let's test it out. All right, there we have it. We set our block down and we got our next shape. So the next thing we need to do is do our collision detection for blocks. Okay, so let's update the isBlockCollided to do the sides as well as other blocks on the board. So the first thing I want to do is I want to get rid of this -10. I don't like to have magic numbers in my code, so I'm going to replace this with a constant. Okay, so I've added 4 new constants, one for the minimum x, the maximum x, the minimum y, and the start y. Let's start with the start y, and I know that's over here in my transform position here, so I'm going to replace that one with start y. Then I'm going to go over here to this one and replace it with not negative min y, but min y. And then inside my foreach, I'm going to do the x check. So I'm going to check that block.x is less than or equal to minimum x, min x, or block.x is greater than max x, then we're going to return true. And then after we check our x and y, we're going to check to see if it's colliding with another block. To do that, we're going to loop through all of our placed blocks in our placed blocks transformed list, and then we're going to compare all those positions. If the x and the y are equal to each other, we're going to return true because we know we have a collision. All right, let's give this a test. And then setting another block on top of that. Okay, that's working. Let's test the left and right collision. Okay, so we're getting stuck into the wall when we collide, and that's because we actually need to check before we move into the wall. Otherwise, we'll get stuck in the wall. So let's change our left and right movement to check before we move. Okay, in our Tetromino move method, we want to check to make sure that we're not inside the wall first. Okay, over here in our moves, I've added this if statement, and I'm saying if not is collided. And then we're going to pass in a new vector2 into our getBlocks method. So we're going to check in our movement position. Okay, checking the walls, left, right, we can't move into the walls. Perfect. Let's try another shape. Perfect. Now let's try something different. Let's try rotating. Okay, we're getting stuck with the rotation, so we need to make sure we check that we can't rotate into a wall. Okay, before I update my rotation, I think I'm going to add another little bit of a refactor here, creating a new method called rotate. It's just nice to keep our methods pretty small. That makes them easier to maintain and update in the future. And I want to call this here rotate. So our rotate method, we're going to do it a little bit differently. We're going to do the rotation first. Then we're going to check if there's a collision. And if there is a collision, Then we're going to rotate back. Alright, so here we have the new rotation method. And so as you can see, I'm rotating it first. And I'm saying if there's a collision at 0, 0, which is its current position, then rotate back. Otherwise, we're going to update the last rotate time because we're keeping this rotation. Let's test that. Okay, I'm moving to the left, going to try to rotate. Won't let me rotate until I move away from the wall. Same thing with the right. It's perfect. It's working great. We're going to do the line clear method next. So the first thing I want to do in order to detect line clears is I want to get a list of the lines that we can check, that we need to check for a line clear. And to do that, I want to create a list, but I don't want to have any duplicate values in that list. So what I'm creating here is called a hash set. And a hash set is basically like a list, but it doesn't allow for duplicates. So now in my for each, I'm adding the y coordinate for the block. I'm going to add that to my list. And then after my for each, I'm going to call a method called check line clears, which doesn't exist yet, but I'll create it right now. So in my check line clears, I'm going to create a list of the lines that are cleared or that need to be cleared. And I don't need to bother making this a hash set because we already know that there's not going to be any duplicates, so we don't need to bother with that. Now I've created a for each loop through the y list, so I'm going to loop through each element in the y list and check if that line is cleared. I'm going to start off by assuming that the line is cleared, and then I'm going to try to prove it wrong, and if it is wrong, then I'm going to set this is line clear to false. So I'm going to create a vector2 int pose that's going to represent the position of each cell in the line, and I'm going to check if that is clear or not. Okay, I'm going to set the default y of the position to the y in the y list. Then I'm going to loop through the minimum x position, so the leftist cell, to the rightmost cell, and increment by one at a time. So I'm going to loop through each cell in the line and check if it's blocked, if there's a block there or not. Okay, so now I want to check if there's a block at the position, so I'm creating a new method for that. And if there is no block at that position, then we know that the line is not clear. We can set it to false, and I can use this break statement to break out of this for loop because there's no point in continuing to loop. So I'm going to implement this method, again pressing Control dot and generating the method. So here's my isBlock at position. I'm going to delete this exception. I'm going to loop through all of the placed blocks and see if there is a block at that position. So now I'm doing an if statement and checking the position of the transform with the position of the vec2 int that's passed in. If there is a match, then I'm going to return true. And then outside of my for each loop, I'm going to return false. Okay, so now going back to my check line clears. So after this for loop, not the for each, but the for loop of the checking the line, I'm going to say if is line clear, then I'm going to add it to my line clears list. After my for each loop, I'm going to say if the line clears.count is greater than 0, then I'm going to call this line clear lines method. So this is just checking to see if there's any lines to clear. Now we need to clear the lines and destroy those game objects. Okay, so here's my clear lines method, which is taking in a list of line clears, and I'm going to loop through each of those line clears, grab the y value, and then I'm creating another vec2 int position, assigning the y to the y from the line clears, and I'm looping through the line. So this code may seem familiar. It's very similar to the for each loop in the check line clears, but this time we're actually going to destroy the game objects. So here we have this position x. We're looping through the x positions, looping through every cell in the row, and then we're going to grab the block by calling this method get block at position. So it's very similar to is block at position, but instead of returning true or false, it's going to return the actual block. So let's implement this one next. So now here's my get block at position method, and it's going to loop through all the place blocks, also checking to see if the positions are the same, but instead of returning true, it's going to return the actual transform. If it doesn't find anything, it's going to return null. Okay, so going back to my clear lines method, it seems to have a problem with my block. I'm using var here. It looks like it defined when I auto-generated the method, it gave it the wrong return type. Instead of GameObject, actually it shouldn't be GameObject, it should be a transform. So that's a problem with using the auto-generate method. It assumed the type and it assumed wrong. But that was because I was using var as the keyword instead of GameObject here. So this block, well, instead of transform. So this block is a transform. And we're going to remove this transform from our list of place blocks. And then we're going to destroy the GameObject. So that will essentially clear the lines. So there's one thing left to do after clearing the line, and that's to shift all the blocks up after clearing the lines. Let's implement that method here and generate this again. So we've deleted all the transforms or all the game objects, but now there's just going to be an empty gap. We need to drop the pieces down one block. So I'm going to loop through every place block, this time shifting the cubes up if they're above the line clear. So now I can't just move them one block. I need to find out how many blocks they need to be able to move. So I need to count the line clears. So here I have a method. I'm just going to loop through all the line clears here, the list of line clears, and I'm going to find out if this particular block is above it or not. Then we're going to increment the move count. And then if the move count is greater than 0, we're going to translate the block. And that will shift all the blocks after a line clear. Let's run this and see if it works. Alright, let's test this out, see if it works. I'm about to clear a line. And look at that, it works. We got our Tetris game. The basics of the Tetris game. That completes this episode. You can find links to the source code in the description. In the next episode, I will be adding more animations, scoring, and more gameplay. Thank you for watching. If you have any questions, please add them in the comments. If you like this video, please hit the like button and subscribe to my channel. Thanks.